Hello and welcome to another free code session. My name is Jason Bach, and I have some code up here for some experiments I've been doing with this whole idea of test adapters and source generators. And it's something that I'm going to use this episode to talk about and what the next steps are. So this episode, and who knows many other ones after this, are going to be based around this idea. But I'm glad to report that the proof of concept MVP idea has shown that this is definitely a possible thing and it has some merit. So I'm going to keep going with it. So yeah, I'm glad I did all this and do my own research. God, that phrase. I'm glad I did that work off camera because it was a lot of stumbling. It was a lot of what does this do? How does this work? And now if I go back and actually look at the documentation for the test platform and the object model and how everything works, I bet it would make more sense. But I didn't find like a tutorial or here's a getting started, or if you want to write one, here's how you do it. I never found it. So, there's a lot of stuff about the architecture and the design of this, but how you actually build one of these was kind of a lot of stumbling. So again, doing that in camera would have been not so much fun. I think that would have been pretty boring, to be honest. And plus I needed to kind of focus on different things and where my brain was going. And I didn't necessarily want to do a video or videos on that. So the result is, again, I think I've landed on something that is worth doing more investigations on. And that's what I'm going to talk about. Before I do that, I just wanted to mention real quick that when this video was recorded, the trailer for The Matrix Resurrections came out the previous day. And I had some, again, this is a geeky thing. If you think about The Matrix, it's all about encoding this huge, virtual world that is directly, connected to your spinal column, to your brain. And so there's some ties there. I think like a lot of people, the first movie just blew me away. I didn't really know what to expect going in, but wow, that was done so well. And it's aged well over time. To me, I can still watch it and go, wow, that was done. There's things with technology that like the cell phones and how the computers look that's showing its time, but, not that the ideas and the visuals still are really, really good. The second and third ones, I felt like they were trying to hit a bar that had been raised so high and expectations so high by viewers that they were never going to hit it. That being said, some of the things I felt like they were being too cerebral and trying to get too deep in a movie. The whole architect speech in the second movie, I had to watch 2 or 3 times afterwards. Watching in the theater, it sounded like gibberish nonsense. It didn't make any sense. Actually watching it later and thinking about what the architect was saying, it actually started to make more sense. But the whole Zion, thing and how Zion had been, I'm getting into spoilers here, but yeah, you know what I'm talking about. I just felt like it was, yes, I get the whole coupled with a form of fusion to make humans as batteries is a real reach in that perspective. But it just felt like it didn't make any sense. So, that being said, I heard that they were going to be making this 4th movie and I really didn't have a lot of hope for it. I was like, oh, is this just a cash grab? Is this going to be really, really bad? How are they going to bring Keanu back and Carrie-Anne Moss? And, how is this all going to work? And I saw the trailer and I said, okay, that is about one of the best trailers I've ever seen in my life. It just, the music, the pacing of the trailer itself, it really made me go, wow, okay, now I want to see this. Now, keep in mind, this is just a trailer and I don't want to see anything anymore. I don't want to hear any more speculation or anything. I kind of want to just say, okay, now go into the movie with just that in mind. And, I think it was like that with The Shawshank Redemption. I didn't know much about it other than I heard it was a really good movie and I watched it and it's a very good movie, but you want to go in not knowing much about it, because if you do, that takes away from an aspect, and I'm just going to leave it at that. So this one, yeah, I just want to leave it with what I saw in the trailer and get the answers by watching it. But yeah, the trailer itself, wow, that was done really, really well. Everything, the music, the callbacks, even if they're subtle, like when he's looking through his hand at the sun, you see those birds, but they kind of flock like what you saw with the squiddies. So the bracelet that Trinity wears when she shakes Neo's hand the first time, some people have speculated that looks like a squiddy. Is she really, alive, or is this a incarnation of her in the Matrix that's trying to lure Neo? Who knows? Lots of speculation, and that's fun. But I also was thinking, when I saw the trailer for the movie Pearl Harbor, that hit me. That was actually, kind of got, in the feels, so to speak. It was very, not like I was bawling, but it was emotional. It really hit. And the movie itself, I never watched because it got really bad reviews. So there's the trailer and then there's the movie. We'll see, but there's hope. Okay, there's hope for, and then it was funny too because people started complaining about, well, why does the Matrix not look like that greenish, washed out look that they had in the first three movies? And I'm like, did you forget how the Matrix was rebooted at the end of, not Reloaded, Revolutions? Thank you, and thank you, Jason. You're welcome, Jason. It looks very clean, happy, serene, peaceful. That's how it's supposed to look. Okay, so let's just, remember that. So remember that, people. Anyway, and then also I thought, oh, a fourth movie that has the word resurrection in it. When's the last time we heard that? And how well did that movie go? Of course, there's no correlation, causation here at all, but it's, yeah, alien resurrection, that was a thing. So, okay. Anyway. All right. So again, this idea is to take a test adapter and have it run where everything is source generated. Okay. Now I want to be really clear. All the work that I'm doing, I'm not actually testing or comparing against any of the test runners that currently exist. There's like a official one for each of the test frameworks, for MS Test, for NUnit, and for XUnit. And I think Fixie has one as well. You can write your own, but as I'm going to be talking about, that's a tall endeavor because you have to actually, hold on. I don't know why I answer spam callers. I think just sometimes it's because, here's a reason. So I think I mentioned this in a video before, is because when I've had to do like any blood work or tests, that people that are calling, they're not calling from the clinic, they're calling from home or something like that. So it'll come in as a private number or whatever. And they're calling you back to give you the information, even though it's all online and I don't need to have them tell me. Anyway, but yeah, it's ridiculous. It's annoying. So where was I? Test adapters. Yes. So each one has one. You could write your own, but you really don't, because each test framework has kind of their own idiosyncrasies and how they load tests and group tests and run them and execute them. And what you do may not be what the framework does. Okay. So I want to be very clear. I'm not comparing myself against what the NUnit.Testadapter does. That's not it. What I am trying to do is say, if I wrote a test runner for NUnit, how would I find the tests and how would I execute them? Okay, given how the test adapter works. And while I haven't done a deep dive into NUnit's test adapter, I'm imagining it does something with reflection to find everything it needs to. Okay, so that's what I said. I'm going to do something that does that. Then I'm going to hard code it, and then I'm going to see how do I get these things to run and how do they compare. And for just experimentation, I'm just saying I want to find methods that have the test attribute on them and then run them. There's this whole assertion framework, assert multiple, all these things that happen. What happens if the test is async? What happens if there's a test case? What happens, tons of stuff that I'm not going to get into. Okay. because that's not my concern. My concern is not all those details right now. I said, let's just do the simple case of finding a method, assume it's static, and then call them, find them and execute them. Okay. So that's what I did. Now, also what I've been doing is here, and this is in the repo that by the time this episode actually gets released, this will probably have become public. Okay. Right now I have it as a private repo because I've just been doing some work. So I just did a whole bunch of random notes on how this all works. And you can see I got to step 2 and then I just kept writing and writing and writing because this was just free form notes. So actually I've done step 3 and well, I haven't done when they use reflection, one that is hard-coded and do perf test. That's really what I wanted to do for step 4. Step 5 is actually write the source generator, which is what I'm going to do in camera in a video. Okay, but I have all these notes here, so if you want to see what I did, I had to figure out how in the world do I actually get this to work. And I was also curious to say, what does this look like when you run it in Test Explorer and Visual Studio as compared to .NET Test as a tool from the command line? And there is differences in how these things work, okay? But as I found out, let's just kind of back up here first, is if you write a test adapter, apparently you want the word test adapter at the end. I'm not 100% convinced on that, but I think that's what you want to do. You definitely want to reference the test SDK. That was one of my first mistakes. I forgot to do that. The test platform object model, that seems to have everything you want. Of course, I'm also referencing NUnit, but notice I'm not referencing like the test adapter package for NUnit. Okay. So then I said, okay, I want to put some tests in here and just something that just pauses it because I wanted to see, like, let's say we had a test that only took 10 milliseconds and then a test that took 2 seconds. And just run them and have them not do anything. They don't fail. They don't do assertions. None of that. Okay. Just as a test method. Now, the first thing, there's basically, from what I've understood, and my understanding of this might even increase as I do this more, is with test adapters, there's basically 2 sides of this. There's a discoverer, and that's where you basically discover all your tests. And as you can imagine, every test framework does it a little differently. So that's up to the framework, and then it basically reports all the test cases back in a standard, well, in a way that is relevant to that framework, but then can be shown in a common way, as you would see in the Test Explorer. Okay. And then there's the executor. The executor actually is told, you go off and execute tests. Now, in Test Explorer, the discoverer and the executor both fire. When you run .NET Test, from what I found, only the executor is fired because the executor in and of itself will also do discovery because it will try to find all the tests and then run them. Okay. And again, we'll get into details here as to how this all works in a moment. So, a couple of different, and then I was also thinking, well, what I really want to focus on is, does .NET Test work? And also, I closed the terminal. Doing it in the terminal here in Visual Studio, it would never work. But if I did it in Windows Terminal and I ran .NET Test, everything worked fine. So, that kind of sucks because I really like having a terminal within Visual Studio, but I don't know why it has a difference where it wasn't working. In any event, I thought, well, how am I going to do performance testing against like launching .NET Test itself from it within a launched code from benchmark.net and get any meaningful performance results? And then I said, well, wait a minute, I can actually there's a way that you can drive these executors and discoverers so that you can do this in benchmark.net. Again, I will show that in a moment, but that's what you end up doing is writing a discoverer and an executor. So let me show you like the reflection versions of these first. So with the discoverer, you need to put this attribute on there with some URI that says, this is my executor or something like that. Again, I've been looking through in here, the NUnit.Test.Adapter, and just kind of digging through their code and seeing what was done there and do any of these matter and what do and don't and blah, blah, blah. Okay. So again, that was a little bit of that experimentation going on, but it seemed like all you really needed is this test discoverer, which means you have to implement this interface. Okay. The message logger is if you want to log anything that will be shown as output when you're in the tests. This discovery context, I didn't really need. The sources are basically paths to assemblies that the engine itself is going to say, look at these and tell me which ones of these have tests. That's up to you. Okay. I forget what's in the context, discovery context, run settings. Yeah. So there's is that it? It'll tell you things like, well, in this case, we can say get settings. Okay. But then you need a string settings name, blah, blah, blah. I just didn't need this. I would imagine you would probably want this stuff for flexibility in different cases for a full-fledged adapter. But in my case, all I'm going to do is look at the sources, load the assembly, go through all the types and methods, and then say if it's marked with test attribute, then put this in as a test case with the fully qualified name being the whole type name and the method name. And then you have to say, where was the source? And this matters. By the way, I found out that the source has to be a valid path to an assembly, because even if you try to fake it, but I think .NET Test won't care, but in Visual Studio, it definitely cares. So you have to actually have the right source. And that matters when we get to the executor. Okay, so again, for an MVP, I thought this was reasonable. The executor side, there's two ways. One, you'll be given the test cases, and this is because you probably just discovered them, so here are the test cases. Or, like in the case of .NET Test, you're just given a list of sources. Go off and execute them. So in that case, what you do is kind of what you had to do before, which is define all the test methods. Okay. In either case, either I'm going to look for the method in this is something that also NUnit.Test.Adapter does, which is groups them by sources from the same source. And then you just load that assembly and then call the method. Okay. Except in here, I actually have to find the method from a type and then invoke it. Okay. And then I record the result. When you run the tests here, I just see if I find the method and then I invoke it. Okay. So that to me is what you do for discovery and an executor if you're doing it through reflection, because you just don't know. You have to look all of this stuff up at runtime. So the idea of source generation is, hey, wait a minute. I can go look at, for example, this class and say, does it have a test attribute on it? And if so, then you know what? When I'm doing in the discovery, just add in a send test case with everything pre-figured out. You already know what the whole list is going to be. Okay. The same thing with an executor. Well, you know what all the tests are, all the test methods are, so just have calls set up to them and record the results. So what I did is, come back over here. In the discovery, that's it. So this is what the source generator would eventually produce, is something like this. Okay. Now the location was a trick because I still need at runtime to know where these assemblies are. So what I'm going to have to do is say for each assembly, or for any project, because this is a project would be targeted by this, it will have a discoverer probably is the right term, and an executor built into that package, because that's what I'm doing here, and it works. It's just fine. Okay. So what I just did is said, okay, for this type, it's in this assembly. Okay. So I'd have to do something to say for all the types within assembly, get the location of it. Here's the executor URI. That'd be the same for everything. And then just print all these out. That's it. Okay. For the executor, it's almost the same thing. Okay. In that I'll say, here's the method I got to call and record the result. And I'll always say, of course, it's passed. So in either case, I don't care if I'm told a list of test cases or a list of sources. I don't care. I'm always going to just defer off to this thing. And then, of course, cancel. You want to have a way to cancel all your runs, but I'm not worrying about that. So this to me is about as best of a comparison, apples to apples, between reflection and what would be a source generated case. So then what I did is I said, well, what's nice about the way to design this is that it's all interface based. So I can inject a dependency. And in my case, I said, you know what? I used to have some logging statements in here, but I've taken them all out because I didn't want logging to get in the way of running performance testing. And I said, let's now use benchmark.net to do some discovery tests to say, okay, well, I know what my sources are because that's all the locations of the tests in there. Okay. And then I will pass that into both hard-coded and reflection. Same thing on the executor side. Okay. I will run the executor here and here. Then I ran these and I said, what is the difference in performance? And so I have my results and here they are. So the discover, let me make this a little bit bigger here. So the discoverer tests, you'll notice that, and this isn't that surprising, is that for hard-coded discovery, it's like 2 orders of magnitude faster than doing it through reflection. It also allocates what looks like about 9 times less memory. I wish there was like a baseline to do with memory diagnoser, but you can just look at it and go, okay, it's definitely a lot less. For the executor, those timed tests ended up being about 5 seconds. So what's interesting is that, the difference in execution isn't as much, but it's also, I think, being washed out in the noise of this test taking too long. You definitely see a improvement in allocations. So that's good. I then just did one 10 millisecond test. And what's funny is it shows that the hard-coded one's like 4.48 milliseconds and execution's 0.45. To me, that's showing that there's almost no difference in execution if you do it this way, but you're saving a lot on allocations. Okay. And if you start throwing in things like, well, what happens if this is a test case? And then I got to pull the values out for to pass them into a parameterized test. You could easily think about, well, what would happen if I did this in a source generator? And then I could find all this out and put in those values in the call site, because if you do a test case with the attribute, they have to be constant values. And then you can just pull those out and stick them in there. So yeah, this seems to have benefit from both the discoverer and the executor side. So now I want to build the actual source generator in a separate project, have this project reference that one, do some shimmying around and changing with where code exists, and then see, does that work? And, the performance testing really would need to be done, because my source generator is literally going to generate what you see here. Okay, let's bring this back down. So I already know from a performance standpoint what the benefit is. Now, there is also a caveat here with any source generator, is that there is somewhat of a trade-off. You're taking time during compilation to come up with this. And so there's a cost involved in doing some execution to actually create these classes. So is that offset? I come back to here because I'm used to, is that offset here? I don't know. Is the time to actually do the source generation actually more than the discovery and the execution and the memory allocation? As much as I love source generators, that is one thing that I have not spent a lot of time. And that's actually one thing I do want to spend time on. So I'm going to put in my notes here. I should actually have the notes in. Let's do step 5, then create the source generator versions. And then step 6, see how long it takes to actually do the source generation. And this one I have to be very specific because I don't want to use the test stuff that I've been showing in previous episodes, because that actually seems to take a little bit of time to set all this up. What I want to really focus on is how long does it take for, I think it's called execute, that method in the source generator to run. Because that's important. If it actually ends up being more than this, if you think about tests, you're just running them all the time. And if you're adding new tests, removing them, and the source generator keeps, updating and doing all this work, are you actually not winning in the long run? So we'll see, but it's at least fun. It's been a fun a fun amount of time just getting this all to work, learning a lot, seeing how this stuff all ties in. And so then the next step in subsequent episodes is to build the source generator. Okay. So I'm really looking forward to this. It's fun. And I just love source generators. And it'll be fun to actually spend the time too to say, what is that cost of the source generator running? If you're building something with a source generator that is going to be executed multiple times in production, and the cost to do it is just once at compile time, rather than having this run all the time and at runtime doing all this reflection lookup, even if you're caching stuff, the hope is that the offset of that compile time work and any increase in assembly size is offset by increases with better, making your performance better and decreasing your memory. We'll see. Anyway, so that's all I have for this episode. Next ones, I'll be building the source generator. So thank you all for watching. Leave comments and questions below. See you in the next episode.